Ever wondered why an elephant stomping on the ground feels like an earthquake, but you stepping on a bug doesn't even register? It all comes down to a simple yet profound formula from Sir Isaac Newton's second law of motion. Force equals mass times acceleration, often written as F equals sine ma. Picture an animation of a cube. Now, this cube represents an object with a certain mass. Mass, in the simplest terms, can be thought of as the amount of stuff or matter that makes up an object. It's a measure of an object's resistance to acceleration when a net force is applied. Now imagine an arrow pushing this cube. This arrow symbolizes force. Force is a push or a pull upon an object resulting from the object's interaction with another object. And finally, envision the cube speeding up as it moves. That's acceleration. Acceleration is the rate at which an object changes its velocity. It's a vector quantity, meaning it has both magnitude and direction. Combine these into the formula F equals sine ma. The force applied on an object is equal to the mass of the object multiplied by its acceleration. This formula is at the heart of understanding how objects in our everyday life move and interact. Consider a car accelerating down a highway. The force applied by the car's engine must overcome the resistance of friction and air drag. The more mass the car has, the greater the force required to achieve the same acceleration. Similarly, think about a soccer ball being kicked. A small force will result in a large acceleration if the ball's mass is small. Yet, if you tried to kick a bowling ball with the same force, you'd find it doesn't accelerate nearly as much. In summary, Newton's second law of motion, F equals sine ma, is a fundamental principle that governs the motion of objects in our universe. It tells us that the force exerted on an object depends on its mass and how fast it's accelerating. Understanding this equation allows us to predict how objects will move under certain conditions, which is crucial in fields ranging from engineering to sports science. It's a simple formula, just 3 elements, but it explains a complex world of motion. So next time when you're watching an elephant stomp or kicking a soccer ball, remember Newton's second law and appreciate the invisible physics at play. It's not magic, it's science.